Hello, all you lovely people. Today I just wanted to show you an interesting project that I've been working on. So what happened is I found this battery laying around, and when I read the value, 10,000 milliamps, I was like, there is no way. There is no way there is actually 10,000 milliamps of capacity in there. So yeah, what I decided to do is build this little contraption to measure the actual capacity of power banks. Right now it's wired on this power bank because I also want to measure this new power bank. This one was actually a bit old, so like you will see the results later. Okay, so yeah, the way it works is I let the current through the amp meter. This is just for testing to measure if everything is working correctly. And then I wire it through this resistor. And this resistor basically makes sure. Oh my god, it's resetting again. Oh my god. Doesn't matter, we'll fix it later. Um, oh, he's going berserk. What the fuck? Oh no, it's okay. Okay, so yeah, this resistor makes sure that there is a voltage drop, and we measure this voltage drop, and then from the voltage drop we can infer what current is running through. So for example, if there is like, this is 1 ohm resistor, and if there is like 1 volt voltage drop, that means that there is 1 amp flowing through it. And like in this case, like if you plug it in, if we like connect the circuit, we see that right now it's flowing 2 amps. That means that there is like two volts voltage drop, and that means that like the power bank is running the current of roughly 2 amps. Okay, so let's get to the coding part here. Oh yeah, we have to log in again. No password, of course not. We need security. Okay. So yeah, we basically just read the files directly from the. No, we read we read the values directly from the files. So the way it works, let me find the documentation here. Yeah, here. So okay, so yeah, this is like the Toradex board, and it like enables you 4 analog pins where you can measure analog values. Analog values just means that you can get like a floating point value, so like from 0 to 3.3 and all the values in between. And yeah, and in order to read those values, you just basically need to navigate to this directory as specified here in the documentation somewhere. It doesn't matter. Yeah, we just need to go to this file, and then we'll see here we have files. Those are not really files, they're like system files, which is basically like computer generates them on the go. Like when you read the file, then the processor reads the value and generates the file. So if we read all of those files, like that, yeah, we can see we get all the raw values from the four input sensors that we have on the board. So yeah, like I said, I basically connected here. I basically connected one of the sensors to the resistor in order to measure the voltage drop, and then using like simple arithmetics to convert to calculate amps. So yeah, let's see how it works in progress, like it did on the beginning of the video, but then the board crashed because. Okay, so yeah, right here I just basically wrote like a simple bash script that reads the value from the input and then outputs it and then saves it to the file, which we then later export to the Excel sheets to calculate the actual capacity. Yeah, so right now, every second, the value is being read and logged into file, and we can double check if the values are correct by making sure that it's displayed the same value. So yeah, it's roughly the same, which is good enough for our use case. So yeah, like I said, now I'm measuring this bad boy. This bad boy has already been measured, and yeah, let's see what results I got. So yeah, the results are right here. Yeah, those are like directly exported values from the file written on Torodex, and yeah, those are the all the measured uh, milliamps. It basically needed roughly here about 2.5 hours to complete the discharge. And yeah, what I needed to do is calculate the average current that was running in the two hours time. And from the average current and the time that it took to discharge, we can calculate the final value, which is our capacity. And yeah, this is the battery capacity. And yeah, so like compared to like 10 ampere hours, that was written on the battery, we can see that it's basically like only has like 30% capacity. And yeah, I'm super excited to see the actual value from the brand new, because I bought this like 1 month ago. So yeah, let's wait and see what what the capacity of this one is going to be. I mean, you don't have to wait. You will just teleport into the future. I have to wait. But it's a sacrifice I'm willing to make. Okay, see you. Okay, just one thing that I also find really interesting. So, like, you might ask, like, where is all this energy from the power bank going, right? So it's basically going all into the heat inside of this resistor. So if we check the temperature, like we can see it's heating up pretty, like it's 70 degrees. So like I could actually cook an egg on this. Like it's hot to the touch. So yeah, this is where basically all of the energy that was stored in the battery is all going into the heat, like into the cables. You can feel they are getting warm. And of course into this bad boy who is taking most of the load. Okay, see you when the battery is fully discharged and I completed the calculation. Hey ho. Yeah, it's me in the future, I guess. Yeah, so this bad boy is still discharging. It's only been like half an hour. I don't know how long it's been. But basically, I've gotten a bit bored. And yeah, look at that. I noticed that this thing heats up pretty, like it's hot. That's all that matters. So yeah, I decided to check out if I could boil an egg or like to fry an egg on it. And like according to Mr. Google here, you need like 160 of freedom units to fry an egg, which is basically around, yeah, this is basically the minimum temperature in order to coagulate an egg. So it's like around 62 degrees. Uh, yeah, so let's see, let's see what we can do. Yeah, like any good recipe, we need a bit of butter first. Beep, beep, beep. Yeah, it's already melting. I love it. Yeah, and I basically use like a styrofoam cube in order to isolate to basically get all the heat up into the top. Yeah, nice. Tasty. Okay, so we got the butter part done, and now the egg part. But this is probably already getting cold. Yeah, I mean it doesn't really have that much power. I mean, it has 2 amps, so it has some power. I mean, I can show it. You can read it on the display. But yeah, still, let's see how if we can get this egg frying. Yeah. Oh my God. Ah, that's too much. Oh my God. Yeah, it doesn't matter. Yeah, let's see. Yeah. I guess we just have to wait. No, 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 no. Before that. Oh my God. Ah, that's just a mess now. Ah, fuck it. I'll deal with it later. Uh, a bit of spices. Yeah, that's going to be nice. Nice and tasty. I love salt. Okay, so see you back in a bit to check on the egg. Oh my god, where is the pause button? And welcome back. So, as you can see, the eggs are cooked. Like, it actually took them a while to cook them because the temperature was constantly around 50 degrees. But at the end, when the water evaporated, it lifted up to 60 degrees. So, like, the eggs coagulated, and, like, I guess it's edible. I ate it a bit, but like I wouldn't risk eating it all. Okay, but leaving this aside, as you can see, the power bank finished with discharging. So yeah, let's look at the results. So here we go. That's the exported data, exported raw data. And then we filtered out all the values that are unimportant, like they're basically zero, and we counted all the seconds, and here is the actual interesting data. So it took about 6 hours and 5 minutes to discharge a whole battery, which is quite impressive, I would say. The average current running was about 2 amps. We can also check how the data looks graphically. As you can see here, the current was at the beginning around 2200, and then it slowly dropped down as expected. There were like some missing data in between, but we are ignoring that anyway. So, okay, and for the actual capacity, when we multiply the average current with the number of seconds, we get 12 ampere hours. And because I only started at around 90%, I think it was around 93, but like let's say 90%, the actual full capacity would be around 13 ampere hours. Which is sadly only 76, or like two-thirds of the specified, because according to the specification, if we looked at the actual power bank that I'm using, which we can find here somewhere. No, I don't cannot find that. Yeah. So yeah, the power bank, that's the power bank that we were testing. And yeah, as you can see, it's supposed to be 12,000 milliamp hours, but yeah, it's only two-thirds of that, so like around 13 milliamps. Yeah. That was all. Thanks for watching. I actually have like a bonus thing at the end for all the nice viewers that actually watched the whole video. I hope you would find it interesting, and yeah, let me set up the bonus for you. See ya. Okay, so the setup is done, and what I basically did is using this power supply, running the wires through the multimeter into this old Samsung phone. And what I wanted to check is basically how much current is being used even when the phone is not being used. So when I actually turn on the phone, like it will around 300 or up to 400 milliamps. But when the phone is not used, it just uses around 50 milliamps, which I don't know. I think it's quite interesting. And I don't know if there is actually any correlation or causation for that, but I basically noticed that when the phone was idling at 50 milliamps, like as soon as I made some noise, or like if I touched the phone, it would immediately jump up to like 100 or 200. Almost like the phone was like being aware what was happening around it, which is kind of creepy. But yeah, so yeah, I hope you enjoyed watching the video as much as I had fun making it, and yeah, see you next time. Bye bye.